Hello everyone and welcome to this presentation. I'm Abdellatif Idrissi from the Capgemini Engineering Company, and today I'm going to share with you our research project which addresses the topic of software energy consumption. So this presentation is entitled the Case-Based Reasoning System for Software Energy Efficiency. I want to begin by show you the outline of my talk, which is divided as any research study into mainly three parts: problem description, methods, and results. But before that, I will introduce the context of this study and also present the objectives and the adopted approach. So let's begin by talking about the context of the study. As you know, software applications are mainly evaluated on their contribution from an economic point of view, as well as on its help to increase productivity. That is to say, developers of applications are generally interesting just by increasing the number of lines which they develop, and not to optimize the code in terms of energy or in terms of execution time, for example. And secondly, software applications have negative impacts. Recent studies have shown that software also have negative impacts on the energy consumption of personal computers, servers, and smartphones, as well as on environment such as pollution. And generally speaking, information and communication technologies represent more than 13% of global electricity consumption and more than 2% of global CO2 emissions. And we are constantly perceiving that these figures are steadily growing. Now, to describe the problem addressed in this study, the problem is, although some guidelines of how to optimize the code and software applications exist, however, they are facing some challenges such as evaluation according to a given context. That is, we can find just some guidelines on the websites, on the net, but these guidelines are not evaluated in not evaluated given a context, for example, which operating system used, which language, etc., etc. And secondly, the second challenge is the lack of capitalization of this knowledge, so that every developers and every programmers have, for example, some good practices and guideline to have a more efficient code and application, but this knowledge is not capitalized into, for example, a platform or into a database in order to be presented for every other developers which want to optimize his or her code. The third problem we are facing is that the application developers often have little knowledge of the subjects of software energy efficiency. That is to say, they aren't aware of the impact of optimization their code on the energy consumption and on the decreasing of pollution issue from the CO2 emission. And finally, developers often have less time to devote to optimization efforts, as I have already said that their main interest and important thing are simply productivity produce more and more code lines. As for the objectives of this study, this research attempts to provide assistance to software developers through improving the energy efficiency of the software depending on the context. Second, better capitalizing on good practices. And finally, reducing the user effort. For the approach adopted in this research, we will try to respond to this problematic by the development of an intelligent model for contextualized recommendation of guidelines. This model uses the case-based reasoning approach and a data structure made up of three kinds of data. The first one is a database which store the guidelines, and the second one stores what we call user cases, and the last one stores what we call use cases. As you can see in the figure, here we represent an illustration for the case-based reasoning schema, which is composed mainly of three stages, such as retrieving and reuse and retain new user cases. Next, we will present the different data sets used in this research. The first one is a guideline database. So a guideline, it's a kind of good practice or best practice of software development that is an advice in the form of a text. The second database is a use case. This data corresponds to the implementation and execution of a computer code in a given context. Thus, a use case is described by the code, the context such as, or for example, type of processing, its language of development, and the operating system, etc. And the profit in terms of energy consumption and execution time. Hence, the implementation of a use case with version V1 and without the application of a guideline, version V0, makes it possible to compute an energy gain. Finally, use case. The user case contains information related to the energy gains of a good guideline used in a given context and also to the ratings assigned by the user to the guideline indicating the ease of its implementation. On the figure, we can see the three kind of data sets for the first one, guidelines, which contains, for example, some information linked to the ID of the use case or the ID of use case V0 and V1, etc., and the energy gain and time gain also, and the user rating. And on the bottom, we can see an example of the use case V0 and V1. Talking now of the architecture and workflow, the user types in the request, the system search for use case corresponding to similar context, then the corresponding user cases are also reassembled, a multi-criteria analysis and clustering by k-means are applied to the energy gains. The context similarity score as well as the user score allow to compute and identify the most appropriate guideline to be recommended to the user. And finally, the knowledge produced will make possible creating a new use case which will enrich the database of the recommendation system. So the guidelines are therefore continuously evaluated through the production of user cases by successive users. The guidelines implemented in a similar context are also evaluated among themselves using k-means clustering and or multi-criteria scoring methods. Here are some results which are obtained and which are promising, having in practice obtained energy savings sometimes better than 30%. And hereafter an example of standardized assessment of two guidelines for a problem of shortest path search. These two guidelines were evaluated in three contexts similar to the user's context, which are noted user cases 1, 2, and 3. As we can see, for example, for the first one, guideline 1 evaluation, and for the first user case here, we can see that we have obtained an energy gain and also time gain, and the user have noted the guideline by a good mark. So the total score of the guideline is indicated here, and the class of the guideline, either a good guideline or a good practice or not, is described also here. So this is some examples extracted from these studies, just in order to show you some obtained results. To conclude, I will tell that we have presented an interactive and intelligent recommender system able to assist the software developers in their tasks for improving the energy efficiency of the software. The interactivity with the user allows to overcome the lack of knowledge, which will be capitalized for future user requests. The perspectives for improvement concern in particular the attempt to evaluate and take into account the effort to implement the code in order to apply a given guideline. Thank you all for your time and your attention.